Kia ora, Weka. I'm going to start videoing some of the practice test questions to help you revising for the common test that's in the last week of term. So I'm juggling this around senior exams and revision for my senior classes. So if there's anything you really want me to do in a hurry that you're having trouble with, let me know and I'll do that. But I thought I might start with some algebra. So this is from practice test 1 and it's questions 4, 5 and 6. So here they go. We've got some simplifying ones there. Then we've got some expanding ones. And lastly, we've got some factorizing ones. So these are all basic algebra skills that we need to have really fluent to solve more interesting problems. So they're pretty boring, right? There's not much context. We're just doing it to get really comfortable with algebra. And for all of these, if you're having trouble with these skills, you can watch what I've done here. You can go and look at some of the more teachy videos that I've done, or you can use the Alpha textbook or Education Perfect. And if you're watching this from another class, feel free to ask your teacher for some references, or you can just leave me a comment and I can help you out. Either is fine. Right, so let's start by simplifying the following. So one of the big ideas that we've got when we start doing algebra is the idea of like terms. And if you're in my class, we looked at that when we looked at people's lunch boxes and saw what we could put together and what we couldn't. So I think we had pretzels and apples and we decided that they were different, right? So the big idea in this question, really those two, is that when I'm adding or subtracting terms, then I have to have exactly the same variables in order to be able to put them together. So let's look at, let's get rid of the message about the battery on the laptop being low and look at what we do. So we've got 3s minus 6s plus 18s. So all of these things have got the variable being s. I've got 3 lots of s, take away 6 lots, plus 18 lots. So 3 take away 6 gives me -3, plus 18 gives me 15s. Now, if you don't like doing the 3 minus 16 plus 18 in your head, I've got plenty of very competent year 12s who still use number lines, and so do I sometimes. So when you're doing a number line approach, you start at 0, you go up to 3, and then we go back 6 to -3, and then we go up 18, and that's where I'm going to cross through the 0 mark, and I end up at 15s. Right? I know most of you are watching going, oh, we don't need a number line, but they are actually really handy. So in part B, we've got 2 different variables, right? We've got 8u, and then we've got take away 3u, but I've got some different variables. I've got -7v plus 4v. So for this one, we keep the u's together and we keep the v's together. And my answer here will be 5u, and I've got take away 7v plus 4v. So that means I'm going to end up with -3v. And I can't do any more with that. That's the end of my simplifying. Definitely don't try and chuck it all into one. These next questions are different because they're about multiplication and division. So here we've got 28p divided by 16. What I'm looking at here is whether I can simplify the numerical thing. So this 28, which is the coefficient of p, and this 16 have got a common factor of 4. So we can divide the top and the bottom of the fraction by 4, and we get 7p over 4. Now there's nothing more to do there. The 7 and the 4 are now in the fractions in its simplest form, and the p is just the variable sitting there. So that's that one. This one here is an example of multiplication, and we multiply the coefficients. Right, so we've got 3h squared times h8 to the power of 5, and we get 24. And when we've got these, we've got the same base, so we just add the powers. Now I've done another video on that, but I'm going to show you just in this space down here why that rule works, right? Because I like us to understand why we're doing things. So we don't want to have to do this every time, so we're just going to do one like this. But the 3h squared means 3 times h times h. And then the times the 8h to the power of 5 means 8 times h times h times h. This is getting boring, so you can see we want a rule to do this simply. Now 3/8 we know are 24. And then this is h once, h times h times h times h times, and you can see I've times h by itself 7 times. So we get our answer 24h to the 7. But the simple way to do that is to recognize this rule that when the bases are the same, we simply add the powers. Right, we'll put that back in again. So it's 24h to the 7. Now this next one is a little bit the same. We can think of this as 8p cubed z times 8p cubed z. Right, what can I do with this? Well, look at those numbers. I've got 8 times 8. That gives me 64. And I've got p cubed times p cubed. And we know from the one above that that means we can add the powers. So it's p to the power of 6. And then I've got z squared. So that was doing it, writing it out like this. And that was fine because we just had it squared. But as many of you watching will remember, hopefully, here's the faster way to do it. If I've got 8p cubed z squared, we can write that as 8 squared. So we square the number, and then we multiply this power here. So we're going to have p to the power of 6 times z squared. So when you're in year 9, it's totally fine to write this out like this. Hopefully, you won't get asked a question where it's to the power of 17. But even if you did, you'd probably see a pattern and you'd stop your writing out quickly. But it's equally fine to know this rule with the powers. And so in an example like this one, let's do another one. I'll just make one up. So this is not in the practice, but it's the same idea. Suppose that I had 4x to the power of 3, y to the power of 5 to the power of 3. It's fine to really know my rules well and know that this is 4 cubed times x to the power of 9, y to the power of 15. Right? And 4 cubed is equal to 64. So that's that one there. So you can see then we didn't have to write it all out, and it didn't take us as long. Right? So we like to be efficient. The last one is looking for a square root, right? And it's the square root of 49 m to the power of 6. And we want to end up with something. The answer is going to be what times what is going to get me back to 49 m to the power of 6. So I take the square root of 49 and I get 7. And instead of, what do I want here? Well, I don't want the square root of 6. I want m to the power of 3. Now, these ones take a bit of getting used to, but look at what we've got here. We've got 7m cubed. And we're looking for a square root of this thing here. So the opposite operation of a square root is squaring. We want to be able to take our answer, square it, and end up with the thing under the square root sign. So let's think about that a bit more with just plain old numbers. What is the square root of 64? Well, it's 8, right? It's 8 because 8 eighths give me back the 64. So up here, my answer here is 7m cubed, because if I do this, 7m cubed times 7m cubed, what do I get back to? Well, first of all, I should change my pen, shouldn't I? There. Well, I get back to 49m to the power of 6, right? Which is exactly what I'm after. So the rule in general when you're square rooting is that you take the square root of the number, but then you halve this power, right? You don't take the square root of 6. Okay, I feel like I'm going pretty slowly. I'm going to speed up a little bit. So this is a little section on expanding and then simplifying. So 3 times y minus 7 means I have 3 times y, 3y, minus 3 times 7. 3 sevens are 21. Let's look at b. We've got 4x squared into 3y cubed minus x. So we take the 4x squared and we're multiplying it by each bit of this. It's just like if I had 5 times 2 plus 7. We could write this as 5 2s plus 5 7s. When we do expanding with algebra, that's exactly what we're doing. Okay, so we're using our multiplication rules and we get 12x squared y cubed, right, this times this, minus 4 and then x squared times x, which is x cubed. And that's my final answer there. Okay, we've got 2 left, and then I think I'm not going to do question 6 in this video, sorry, because it's getting a little bit too long and maybe a little bit too boring. So we've got negative 5t times 3t minus 4. Multiply this by this, and we get negative 15t squared. We multiply this by this, always keeping the sign with the number, and I get plus 20t. The last one has got a couple of bits in it that we have to put together slowly. So let's start by writing it out. Write out this. Now we start expanding. So this bit gives me negative 28w plus 56 minus 15 here. Now be really careful here. I've got minus 3 times minus w, which gives me plus 3w. But I'm not finished because I haven't collected up my like terms. I've got negative 28w here, plus 3w gives me negative 25w. I've got 56 here, minus 15 here gives me plus 41. Now I haven't checked the practice test schedule that's up on Google Classroom, so I'm hoping I haven't made any mistakes, but 9 Weka, I am trusting someone out there to tell me if I have mucked something up. So please leave me a comment or send me a nice email if I have. I'll be back with some more videos, as I said, over the next couple of days or so, possibly not till the weekend. Let me know which bits you want me to do next. Thanks for watching.